have you ever wondered how energy transfers in the world around us? That's where the fascinating field of thermodynamics comes in. Simply put, thermodynamics is the study of energy and its transformations. It's a vital piece of the puzzle in understanding how our universe operates. Now, why is this important in chemistry? Well, chemistry is fundamentally about reactions, and reactions are all about energy changes. Whether it's the energy required to break bonds in reactants or the energy released when new bonds are formed, thermodynamics helps us quantify these changes. But how do we study these energy changes? That's where the concept of systems comes into play. In thermodynamics, a system is the part of the universe we're focusing on. It could be a test tube, a car engine, or even an entire planet. By defining our system, we can observe and calculate the energy changes happening within it. Thermodynamics helps us understand the energy exchanges that shape our world. Imagine a cup of hot tea in a room. Would it stay hot forever? Well, we know it wouldn't. The teacup here is a perfect example of an open system in thermodynamics. In an open system, there's a free exchange of both matter and energy with the surroundings. In our case, the teacup loses heat, an energy form, to the environment. This is why the tea doesn't stay hot forever. Simultaneously, the aroma of the tea, a form of matter, also spreads into the room. This two-way exchange is a defining feature of open systems. They're not isolated from their surroundings. Instead, they constantly interact and engage with it. Whether it's a cup of tea cooling down or a tree absorbing carbon dioxide and releasing oxygen, open systems are all around us. So an open system, like our cup of tea, can exchange both matter and energy with its surroundings. What if we put a lid on our teacup? Now this is where the concept of a closed system comes into play. Imagine that cup of tea we talked about earlier, but this time we've placed a snug lid on top. In a closed system like this, though the tea is sealed off from the external world, it's not completely isolated. Energy can still find its way in and out. The heat from your hand, for instance, can seep through the cup and warm the tea. But here's the catch. While energy can freely move back and forth, matter cannot. The tea leaves, the water, and the sugar, they are all trapped inside the cup. They can't escape, and nothing from the outside can get in either. This is the essence of a closed system. It's like a party where guests can send texts to their friends outside, but no one can leave or enter. So, a closed system, like our covered teacup, can exchange energy, but not matter, with its surroundings. Now, what if we wrap our covered teacup in a thermos? Imagine this scenario. This is what we call an isolated system in thermodynamics. Now, what makes an isolated system special? In an isolated system, such as our thermos-wrapped teacup, there's a complete cutoff from the surroundings. It's like being in a sealed bubble. No matter or energy can get in or out. Let's think about our thermos-wrapped teacup for a second. The tea inside remains hot for a long time, right? This is because the heat energy from the tea cannot escape to the surroundings. Likewise, the cold air from the outside can't get in and cool down the tea. Everything is locked in, creating a self-contained system. This is the essence of an isolated system. It's a perfect example of a system that is completely insulated from any external influence. An isolated system like our thermos-wrapped teacup can't exchange energy or matter with its surroundings. So, how do these different types of systems matter in the real world? As we've seen, open systems can exchange both matter and energy with their surroundings. Think about a boiling pot of water on your stove. It's losing water to the air as steam and gaining heat from the burner. Closed systems, on the other hand, can exchange energy but not matter. Imagine a sealed container of water being heated. The water can't escape, but it's still gaining energy from the heat source. And then we have isolated systems which can't exchange either matter or energy. Picture a thermos full of hot soup. It's designed to keep the soup hot by not allowing heat to escape or enter. These concepts are not just textbook theory, they're vital in practical applications, like engineering, where we design systems to control energy and matter flow. They're crucial in environmental science, where we study how energy and matter move in ecosystems. Understanding these systems in thermodynamics helps us grasp how energy moves in the world around us. Remember, every sip of tea is a lesson in thermodynamics.